Yeah, welcome back to our revision class. Today we are going on Chem 101 revision class. This is going to be part 1, and part 1 we are going to be revising 2021 to 2022 past questions. Just like we've been always doing, I will just we'll look into the question, we'll know the answer and know why the answer is that. So I will also advise us to read more deep into what we have done. I know that we've seen the maths revision class. I know we've seen the physics revision class. This is the chemistry revision class, and then the practical revision class will also be done and uploaded on my YouTube page. So I advise us, please keep asking your question on the comment section on the YouTube page, and ensure you subscribe to this channel. Okay, like the videos, and God will keep keeping us. Okay, without wasting much time, we go to question number 1, 2021 to 2022. It says lithium, sodium, and potassium are in the same group in periodic table because they have the same A, atomic radius, B, electronic configuration, C, ionization energy, D, number of valence electron. Okay, we're asking if lithium, sodium, and potassium are in the same group in the periodic table because why are they in the same group? Now, there is something I want us to learn about this. It's a very simple something. There is something I call PSG electron. PSG electron. You know the club called PSG. Okay, so use that to remember it. So I call it PSG electron. This P is called period. S is called shell. My G is called group. And my E is called valence electrons. So what I do here is I say elements that belong to the same period will have the same number of shell, and elements that belong to the same group will have the same number of electron in their outermost shell, or you call it the same number of valence electron. I repeat, elements that belong to the same period will have the same number of shell, and elements that belong to the same group will have the same number of electrons in their outermost shell. So lithium, sodium, and potassium are in the same group. Why? They are in the same group. Why? Because they will have the same number of valence electrons. So, number of valence electrons. So, option D becomes the answer. I believe that is very clear. Option D becomes the answer. So, we move on. Number 2 says elements from the left to right in a period of the periodic table. Elements from the left to the right in a given period of the periodic table shows A, similarity in chemical properties, B, steady decrease in electronegativity, C, steady increase in atomic number, D, similarity in electronic structure. Now, our answer there should be C, which is steady increase in atomic number. As they move from, as element moves from the left to the right in the given periodic table, there will be increase in atomic number. As they are moving from the left to the right, they are increasing in atomic number. So we should know that across the period in a periodic table, atomic number of element does what? Increases. As we move from left across the period, atomic number of elements does what? Increases. Master that. Question number 3. An element which has atomic number 11 is likely to have similar chemical properties with another element having atomic number what? I repeat, the element which has an atomic number 11 is likely to have similar chemical properties with an element with atomic number what? Now, in this case, we want to know the element is going to have a similar chemical properties with. Now, let's note down this. That 2 different elements are likely to have similar chemical properties when they have the same number of valence electron it is the valence electron or the electron in the outermost shell that tells about the chemical properties of an element. So when two elements have the same number of electrons in their outermost shell, they seem to have similar chemical properties. These chemical properties we are talking about is based on their bonding and how they react with other elements in their environment. So we say two different elements are likely to have similar chemical properties when they have the same number of valence electrons. So this type of electrons are found in the same row. I repeat, this type of elements are found in the same row on the periodic table. So they are found in the same, remember we say PSG electron, PSG electron. So they are found in the same group. Hope you understand. They are found in the same group, or you call it the same row on the periodic table. Now, if you go to the question says an element with the atomic number 11. If you go and check the element with the atomic number 11, you see that it is sodium, Na. It has atomic number 11. Okay, let me write it down. It has atomic number 11. Now, in that is row, all the elements in that row in the periodic table will have the same electrons in their outermost shell. Okay. From the one we have 7, 9, 18, 19. 19 will be, let us check why 19 will be. 19 is potassium. Now, let's see this one. If you write the electronic configuration for this, we have 1s2, 2s2, 2p6, 3s1. Electronic configuration for this will be 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s1. If you observe, they have one electron in their s orbital. In their s orbital. So they will have similar chemical properties. If you check others, you will see that they are not going to be this. Only this guy, potassium, that will be looking like this, and the number of electrons in the s shell. Do you understand that now? So according to this, my PSG electron, elements, we say two different elements are likely to have similar chemical properties when they have the same number of valence electrons. When they have the same number of valence electrons. I would say this type of elements are found in the same row on the periodic table. They are found in the same row on the periodic. I would like you to go to the periodic table and check another element that will behave, that will have similar property with sodium in that same row apart from potassium. Okay, we go to question number 4 now. It says, which of the following is not an elementary unit of a chemical substance? Elementary unit means the unit of measurement. Yes, we use atom. You can say 5 atoms of this. Good. We use molecules. Yes, we use mole. We use ion, but we don't use electrons. So option B becomes the answer. Number 5, which of the following compound has the same molar mass? Which of the following compounds have the same molar mass? Now, if you check, remember how to calculate molar mass. That is question number 5. If we check molar mass, let's see. Let's say for molar mass of CaCO3. The molar mass of CaCO3 will be 40 plus 12 plus 16 times 3. And that gave me 100. What of for KHCO3? That will give me 39 plus 1 plus 12 plus 16 times 3. And that produces 100 again. What of for NH4 2SO4? That will give me 14 and 4. Hope you know. So 14 plus 4 times 1. And all will be multiplied by 2. Then plus, so S is 32 plus 16 times 4. When you do this, your small mathematics is going to give you 132. If you watch, this one and this one have the same molar mass. So option A will become the answer. Option A will become the answer. That is question number 5, which says that which of the following compound has the same molar mass? So option A will become the answer. 1 and 2. Okay, number 6. What is the molar mass of a substance if 0.4 mole of the substance has mass of this? What is the molar mass of a substance? Okay. Question number 6. What is the molar mass of a substance? Now, remember your formulas you use in the secondary school, that amount, which is measured in mole, is equals to mass, which is measured in gram, over molar mass, which is measured in gram per mole. So, in this question, they say, what is the molar mass? I'm looking for N. What is the molar mass? No, I'm looking for molar mass. That is M. I'm looking for molar mass, okay? What is the molar mass of a substance if 0.4 moles? That means N is given as 0.4 moles. Then, if 0.4 moles of the substance has a mass of 25 grams, they get me M to be 25 grams. And I'm looking for this. If you make this summation of the formula, you are going to be having that MM equals to, that will become MM times N equals to M, so that M becomes M over N. We have our M to be 25 and we have our N to be 0.4. When you do such, you will see your answer will give you 62.5. 62.5 gram per mole. 62.5 gram per mole. So, and that should be option C. Option C. So mark this formula, that amount in mole is equals to mass over molar mass. Mass is measured in gram, molar mass is measured in gram per mole. That is question number 6. We go to question number 7. What is the amount of gold present? What is the amount of gold present? You see, that is almost similar question. Let's see. What is the amount of gold? Amount means mole. They're asking me for N, which is measured in mole. What is the amount of, this is mass over molar mass. So they gave me that, what is the amount of gold present in 15.5 gram? M equals to 15.5 gram of pure gold, gold welding ring. Then they have the molar mass of gold is 197. So the amount becomes 15.5 over 197. And if you do that properly with your calculator, you'll be getting 0.079 moles. Okay, and that is option A. Still mark this formula. So mass, molar mass, then amount. So we'll go to question number 8. Go to question number silver atoms. Okay. Calculate the number of silver atoms in pure silver bracelet that has a mass of this. We are calculating number of silver atoms. Now, when we talk about atoms, there is something you must know. Look at this formula, that N is equals to number of particles. Number of particles, or number of atoms. Particles, atoms over Avogadro. Avogadro's number. Let's use like this. Let's write it like Avogadro's number. So remember that this guy is mass over molar mass. So if you observe, number of particles now, number of particles, let me call it NP. Number of particles will now become N times Avogadro. Do you get that? But N is mass over molar mass times Avogadro. So mark this. Number of particle, or you say number of atom, is given like this. So let's look at this question. It says, question number 8, calculate the number of silver atoms in silver, calculate the number of silver atoms in a pure silver bracelet that has a mass of 35 grams. They gave us that the mass is 35 grams. And then they gave us that molar mass of silver is 108. Okay? And they gave us that Avogadro constant is 6.02 times 10 raised to power 23. Please, you have to have this up there. So NP now will now be equals to mass over molar mass times 6.02 times 10 raised to power 23. And if we do this carefully, as much as we can do it, we are going to be having 1.95 times 10 raised to power 23 atoms. And that is option D. So I want us to master this formula. Remember the other one was only this. And when they say number of particles or number of atoms, this is it. You have to multiply mass over molar mass times the Avogadro constant. I believe that is very, very clear. Then that is for question number 8. Question number 9. Calculate the mass of Question number 9. Say calculate the mass of 0.105 moles of Na2CO3 dot 10 molecules of water. We should calculate the mass. Okay. They gave us the mole. N is 0.105 moles. Okay. And another thing they gave us was the molar mass. How to calculate the molar mass was given to us. So if you calculate the molar mass of this, you are going to be having 23 times 2 plus 12 plus 16 times 3 plus water now 10 times 18. Remember that what we are calculating is molar mass is Na2CO3 dot 10 molecules of water. So Na 23 times 2, okay. C carbon is 12, oxygen is 16 times 3 plus water and 10. Water is 2. 16 plus 2 times 1 is 2 plus 16 is 18. So by so doing that, you have that the molar mass of that compound becomes 286 gram per mole. So the question says we should calculate the mass. Mass becomes amount times molar mass, and that becomes 0.105 times 286. This will give us 30 grams, and that is option C. I believe what I did here is very clear. We are still using the same old formula, and then we are arriving at something very good. So we'll go to question number 10 now. Question number 10 says, a chip used in microcomputer contains a chip used in microcomputer does what? Contains 5.74 times 10 raised to power minus 3 grams of silicon. Calculate the number of silicon atom in the chip. It contains, they gave us the mass, 5.74 times 10 raised to power minus 3 gram of silicon. Now also calculate the number of silicon atoms. Number of silicon atoms, that is NP. Okay, and they gave us the molar mass of silicon, Si. Molar mass of silicon to be 28. And they gave us Avogadro to be what now? 6.02 times 10 raised to power minus 23. So remember that I said that NP is still there, is equals to mass over molar mass times NaV. So the mass here is given as 5.74 times 10 raised to power minus 3 over the molar mass of the compound, which is 28, times Avogadro constant, which is 6.02 times 10 raised to the power 23. So if you do your calculation well there for that question number 10, you're going to be having 1.234 times 10 raised to the power 20, and that will give you option C. If you observe, the calculations that we have been seeing so far are mostly based on N equals to mass over molar mass. And I pray if such comes out in the exam again, we will not be having difficulty in addressing it. Okay. Now we go to number 11. Question number 11. It says, the labeled I1A to 7A and group O are referred collectively as, the answer of that is periodic table. That is how periodic table is being labeled, from 1A to 7A and O. Because if you watch the other options, we have transition elements, no. Representative elements, no. But there are some things I want to tell us. We should note that elements in the S and P block are called representative elements. Elements in the S and P block are called representative elements. Elements in the D blocks are called transition metals. Elements in the D block are called transition metals. Elements in the F block are called inner transition metals, or you call them the lanthanide and the actinide. Elements in the F blocks are called inner transition metals, or you call them the lanthanide and actinide. Another one. Elements in the X block consist of subgroup 1A and 2A. Subgroup 1A and 2A. Elements in the S block consist of subgroup 1A and 2A. Elements in the P block consist of subgroup 3A and 7A. Elements in the P block consist of subgroup. That means the S and P block runs from 1A, 2A, 3A up to 7A. Remember that they are called representative elements. That means elements that run from here up to here. They are called representative elements. Okay. Elements that run from here to here and here to here are called representative elements. Okay. And also O. Okay, that changed the answer. Remember, I didn't see that. Question number 11. It says the label 1A to 7A and group O are referred to as, did you see that? That should be, remember I said that elements in the S block consist of subgroup 1A and 2A, while elements in the P block consist of subgroup 3A and 7A and also 0. So from 1A, the question now says, from 1A, question number, from 1A to 7A, from 1A to 7A and 0. So that is element in the S and P block. And elements in the S and P block are called representative elements. So coming to question number 11, the answer is going to be option C, representative elements. Option C, representative elements. So that is very, very correct. Option C, representative elements. Number 12. Okay, let me conclude. I said elements in the S block consist of subgroup 1A and 2A. Elements in the P block consist of subgroup 3A and 7A and O. Elements in the D block consist of subgroup 1B to 7B. Elements in the D block consist of 1B to 7B. Remember that elements in the D block are called transition metals. So transition metals are from 1B to 7B. An element in the F block consists of rare earth metals. Rare earth metals, rare, R-A, R-E, rare earth metals. So element in F block, now they call rare earth metals. So we have seen that elements in S block and P block are called representative elements, and representative elements run from subgroup 1A to 7A and 0. Elements in the D blocks are called transition metals, and they have consist of subgroup 1B to 7B. Elements in the F blocks are called inner transition metals, or you call them lanthanide and actinide, and they consist of the rare earth metals, or you call them lanthanide and actinide. So I think that information is very, very useful. So that shows us why option C is our answer in question number 11. Question number 12. It says, what is the trend of metallic character as you move from left to right in the periodic table? What is the trend of metallic characters as you move from left to right in the periodic table? Okay. Now write down, see, metallic character decreases as we move from left to right across the period. Metallic character will decrease as we move from left to right across the period in the periodic table. Okay, this is because atoms are more ready to accept electrons. We say metallic character decreases as we move from the left to right across the period in the periodic table. Why? This is because atoms are more ready to accept electrons to fill the valence shell rather than losing them to remove unfilled shell. They are more ready to what? To accept electrons so that they can fill their outermost shell rather than losing electrons so that they can remove the outermost shell. Are you there? However, metallic character increases as we move down the group. Metallic character will increase as we move down the group. But when we move from left to right or across the period, metallic character will do what? Will decrease as we move from the left to the right. Mark that. So option A becomes our correct answer there. Say decrease. Question number 13. The periodic law states that option I says chemical and physical properties of an element. I says when elements are arranged in order of increasing atomic number, there is a periodic repletion of their properties. I says element having closely similar properties will fall at definite interval along the list. Now, when you read this question at first, you will think that they are asking you about the modern periodic law. First of all, I will state the modern periodic law for us. Then we will now look at what the examiner really wants in this his own question. Now, the modern periodic law states that the chemical and the physical properties of elements are periodic function of their atomic number. I repeat, the modern periodic law states that the chemical and the physical properties of elements are periodic functions of their atomic number. Remember that in this case, we are using atomic number. But when you come to the Mendeleev's definition, it says that the chemical and physical properties of elements are periodic function of their what? Atomic mass. Mendeleev was talking about atomic mass. He arranged according to atomic mass. Why the modern periodic table is arranged according to atomic number. Please mark this. Okay. But that is not the case in this thing. But before Mendeleev put up his own periodic table, some persons also worked on it. We have first person like John Newland. John Newland says that he observed that when elements are arranged in the ascending order of their relative atomic mass, remember, atomic mass, both Newland, Dobrynin, Mendeleev, they're all arranged according to atomic mass, because periodic table arrangement of elements in the periodic table started when the known element of that time where the atomic mass were all known. So they started arranging because they believed that they have similar, there is something about this, their atomic mass, when you come to the arrangement and how they relate in their chemical and physical properties. So John Newland observed that when elements are arranged in ascending order of their relative atomic mass, that is, we are arranging them as the atomic mass increases, similar properties will occur in every 8 elements. So it was John Newland that brought about what we call the octave arrangement, which is or you call it the musical something. Do, re, mi, fa, sol, la, ti, do. That is, after the 8, you will now see, it will now be repeat. It will repeat itself in similar chemical properties with the first one. What this guy is trying to say, we have, if you have 1, 2, 3, 4, 5, 6, 7. Now, do, re, mi, fa, sol, la, ti, do. The next, number 9, we have similar chemical properties with number 1. Number 10, we have similar chemical properties with number 2. This is what John Newland was saying. And it is called his own method of arrangement. And that is his own law, octave law. It's called his octave law, or we call it the musical note. Then, Dobeliner also noticed that a particular group of 3 elements with similar properties have the same relationship with their relative atomic mass. Dobeliner brought about what we call the triads. He said if you take 3 elements, that if you add this plus this and divide it by 2, you are going to get the atomic number or mass of the center one. If you bring 2 elements consecutively, add the atomic number of this one to the atomic number of this one, sorry, atomic mass of this to the atomic mass of this, and divide it by 2, you are going to get the atomic mass of the central one. And that is what we call Drobeliner triads. Okay. Now, combining all these laws, let's now see what the examiner wants us to know. It says, question number 13, periodic law states that the chemical and physical properties of an element, that statement is not complete, so we leave that. Number II says, when elements are arranged in order of increasing atomic number, there is a periodic repetition of their properties. Yes, that was what this guy says. When you arrange them in the yes, he said it. Even Drobeliner also confirmed that also. That is one. I say element having closely similar properties will fall at definite intervals along the list. Correct. Correct. So they will fall. They have closely similar chemical properties. They will fall along the list. So if you observe this, only I and I are correct. So we have option D to be the correct answer there. But then, if the question had said we should state the Mendeleev periodic law, we'll be talking in terms of atomic mass. But if you say we should state the modern periodic law, we'll be stating it in terms of atomic number. Please, these 2 things should be aware. Mendeleev, then the modern periodic law. Question number 4. Question number 14. Question number 14. Radium 220 has half-life of 555 seconds. It means that every 555 seconds, this radium 220, half of it will decay. Hope you understand now. So, having that in mind, you now say what fraction will be left after 555 seconds? It's half of it. Every 555 seconds, half of the amount of element that is remaining there will go. So option A becomes the answer because option A has half. Now, number 15, the nuclear theory of atomic structure was propounded by option B. Rutherford was propounded by. At the center of the atom, proton, neutron are located in the nucleus, which is at the center of the atom. And then the electrons are distributed around the nucleus, and it occupies most of the volume of the atom. That is what Rutherford's model is talking about of atomic structure. It says proton, neutron are located in the nucleus, while electrons are distributed around the nucleus. And this electron occupies most of the volume of the atom. So going back to question number 15, he said the nuclear theory of atomic structure was propounded by Rutherford, and that theory is that electron, proton, and neutron are located in the nucleus, while electron moves around the nucleus. That is the nuclear theory, should we have been asked. Number 16 says radiation ionizes matters as they pass. Radiation ionizes matters as they pass through it. The most ionizing is, they say option A is beta, option B is gamma, option C is alpha, option D is X-ray. Our answer there is option C, alpha. Alpha is the most ionizing. Alpha is the most ionizing. Let us see something about that. Alpha, they say, is the most ionizing. Now, why is alpha the most ionizing? Listen, because of the large mass of alpha particle. Alpha particle has a very large mass. It has the highest ionizing power. Because of the large mass of alpha particle, it has the highest ionizing power and the ability to damage tissues. It has the highest ionizing power and the ability to do what? To damage tissue. So when we say ionizing, means removing ions, and once it removes ions, it damages that tissue. But then it has the least penetrating power. It has the least penetrating power. Let me explain something to you so you understand. That is why it is this alpha particle that is used as preservation. Example now, I have this an apple I want to preserve. I want to preserve this apple. So I will preserve it using alpha. I will preserve using alpha particle. Now, this alpha particles on the surface of this apple now, any organism that is on the surface of this apple, this alpha particle will ionize it and destroy it. That's why we say that it has the highest ionizing power and great ability to damage tissues. So it will damage the tissues of the organisms that are wanting to spoil this apple. Do you get that now? Now, remember we also say that they have the least penetrating power. That means it does not really penetrate. So it will not affect my apple. It will not penetrate inside my apple as to go and affect, so that when somebody, the person that will eat it, the thing will now start affecting the human being. No, it will only stay in the surface and be ionizing the microorganisms, breaking their tissues that have landed on this apple, so that they are going to destroy or make this apple to rotten. But then they have least penetrating power. They cannot penetrate the apple. So when the final consumer gets hold of this apple, remember that this apple, most of these foreign apples we eat came all the way from Europe. Now, all those way from Europe, they stay like up to months in the ship. So as they are coming, there is tendency of them spoiling. So they preserve them using alpha particles. Why they are preserving them using alpha particles is that alpha particle cannot penetrate it as to alter the nutrients of the apple or make it poisonous to the final consumer. Yet it will stay on the surface of the apple and deal with the microorganisms that are wanting to act on this apple. Then when the final consumer picks the apple to eat, it goes to wash. That's why we are encouraged to wash our fruit very well. It goes to wash it. As it washes away the ionizing alpha particle. Then it can eat, because the thing cannot penetrate, because it has a very low penetrating power. I think I've done justice to that. So we say that alpha particles have highest ionization power. Why ionizing power? Because they are large in mass and they have the least penetrating power. That is for question number 16. So we go to question number 17 now. We go to question number 17 now. Okay. Consider the nuclear reaction. Okay, they want us to consider this nuclear reaction. What is there is that, remember that whatever is here is what's going to be here. 11 plus 4 will give us 15. So if 11 plus 4 will give us 15, that means whatever is going to be here, let me put X here now. Whatever is going to be here, 11 plus 4 is 15. There's already 1 here, so I will have 14 here. So that 14 plus 1 will give us total of 15. Then 5 plus 2 is 7. There is 0 here, so it's going to still be 7. And we are going to be looking for the option that has that. We have 14 and 7. Oh, 11 plus 4 is 15. So we have 14 there. We have 14 there. We have 14 there. And we should have 7. So that will give up option D. That is, which is C, carbon 14. Yes, C, 14 and 7. That is that. We'll go to question number 18. Radiation with the greatest ability to penetrate matters. Remember, we have talked about that alpha particles are the least in penetrating. Okay, which one has the highest penetrating power? It is number 18, which is gamma rays. It has the most penetrating power. So remember that gamma ray and X-ray has this similar ability to penetrate. That is why when someone wants to take X-ray, they flash it. Someone want to look, maybe there is a fracture in the bone, but the bone is inside the body. Want to know the amount of damage. The person will pass through X-ray, which is almost like gamma ray because they are electromagnetic rays. Hope you understand. So they penetrate, they pass through the whole body, pass through the cells, and go to film the skeleton of the person. You see, they have high penetrating power, but the one that has the highest penetrating power here is what? Gamma ray. Mark that. That is option C. Number 19. If two elements X and Y are combined to form more than one compound, then the mass of X, which separately combined with the fixed mass of Y, must be in simple ratio. This law is law of what? Multiple proportion. This is learned in secondary school. You can go and revise your note on law of multiple proportion. Remember, we have this law of chemical combinations. More of them. We have law. One of them is law of multiple proportion. We have conservation of matter. That one that says matter can neither be created nor destroyed in a simple chemical reaction. Then we have law of definite proportion. You need to go and know what law of definite proportion is. It's in the notes. And we have reciprocal proportion. All those law of chemical combinations, you have to master them. Go to question number 20. Why do we emphasize the valence electron in an atom when discussing the atomic properties? Now, why do we emphasize in the valence electron? Option C is the answer. Why? Because it says valence electrons are involved in the interaction between one atom and the other. I have said this in the beginning when I talked about PSG electrons. When I talked about PSG electron, that elements that belong to the same group, we have the same number of electrons in the outermost shell. And in this electron in the outermost shell that tells us about their chemical properties because it tells us how they are going to relate with other electrons or atoms in the environment. Okay, that's question number 20. We move to question number 21. What is the most important relationship between elements in the same group in the periodic table? What is the most important relationship between elements in the same group? Look at elements in the same group. We have the same number of electrons in the outermost shell, and that is option C. They have similar chemical properties. Yes, if they have the same number of electrons in the outermost shell, they will have similar chemical properties. 22 now. Which of the following electronic configuration represents that of noble gas? Remember, noble gas are inert gases. They can't react. Why? Because they have a completely filled electron. They are stable. Okay, if you watch, option D says 2 and 8. 2 and 8. If you are to draw that, you have 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. Very filled up. They don't. This atom now does not need to react because it's stable. Its outermost shell is filled up, even its inner shell is filled up. So this type of elements are, or this type of gases or elements are called noble gases. Okay. Number 23, the atom with 10 proton and 12 neutron has an atomic mass of good. Okay. 23. Remember that in chemistry we write something like this. I prefer to, we have something like this, which is this atomic number, while this mass number. But I prefer to write it like MA. This is my mass, and this is my atomic. Okay, so talking about question number the atomic, okay, atoms with 10 protons. That's question number 23. Question number 23. Now, proton here is 10. Proton is 10. And neutron is 12. Mass number is proton plus neutron. So, which is 10 plus 12, which is 22. That is mass number. Proton plus neutron. So, you use that formula that mass number is equals to number of proton plus number of neutron. So mass number is equals to number of proton plus number of neutron. Should they ask you to find this, you use this formula to evaluate whichever one you might be looking for. So that one is settled there. That's option D will become the answer to that question. Then we go to 24. Proton and neutrons are contained in the, remember, Rutherford's atomic model. He said that the proton and the neutron, they are contained in the nucleus. And this nucleus is at the center of the atom. Then electrons are revolving around the nucleus. So option B will be the answer. So we'll go to question number 25 now. Question number 25. It says the law of conservation of matter is also known as law of conservation of matter is also known as, this is one of the law of chemical combination, is also known as law of indestructibility of matter. Law of indestructibility of matter. Remember I said that law of conservation of matter is that matters can neither be created nor destroyed in a simple chemical reaction. So you can't create them, you can't destroy them. When you balance a chemical equation, what is in the right hand, the amount of elements that are combined in the right hand will also be, if you calculate in the left hand, you also see them. This can only be destroyed or created in a nuclear reaction. But in a simple chemical reaction, matters can never be created nor what? Destroyed. So it is also called the law of indestructibility. Question number, the maximum number of electrons in the p orbital. Okay, the s orbital will have highest number of 2 electrons, while the p will carry highest number of 6, the d will carry highest number of 10, and the f will have highest number of 14. It means that when you are filling this electronic shell, when you are filling the s shell, you have 2. Now, remember that there is difference between orbit and orbital. I want us to know that there is difference between orbit and orbital. Let me use this opportunity to explain that. An orbital, let me explain orbital. An orbital is a place where the probability of finding an electron is high. An orbital is a position where the probability of finding an electron is very high. So when you come to the s orbital, you are going to have 2 electrons. P orbital, we have 6. That's option B. Let's go to 27. It says expression or calculation between quantities of reactants and products based upon the concept given in the balance equation for their reaction is called chemical stoichiometry. That is option B. Chemical stoichiometry. When you are talking about stoichiometry, you are doing chemical calculations. Move to question number 28. The unit of 1 mole of an atom unit of 1 mole of an atom is, according to Avogadro, he say it is 6.02 times 10 raised to power what? 23 atoms. That is it, according to Avogadro. So that should be option C. 99. How many moles of nitrogen atoms are contained in 9.34 grams of nitrogen? Remember, we have done this calculation so much in this our study. Let's repeat again. How many moles? We are looking for moles, which is amount. We don't know. He said how many moles of nitrogen atoms. Now they've mentioned atoms. Remember that atoms and particles are alike. So I say number of atoms or particles is equals to amount times Avogadro's number. Remember, while amount is mass over molar mass, times Avogadro's number. Now, then the number of particles now becomes, they gave us the mass of this thing to be 9.34 grams, and the molar mass of nitrogen here is 14. You are now going to multiply by Avogadro number, which is 6.202 times 10 raised to power 23. If you have done this very well, your answer will be looking like option A, which is 0.667 moles. 0.667 moles. That is it. So I believe we have that calculation sense already in us. That is question number 29. We go to question number 30 now. The number of any element X can be represented. We have represented this before in this course of this class. I've represented that before. I say it can be represented as AZ, or me I represent them as MA. This is mass number, this is atomic number, this is mass number, this is atomic number. So if you look at that option there, we have AZ, option AZ, option, that's number question, option D. 31. It is found that nuclei with Z equals to Z, which is 83, are less stable and therefore prone to disintegration. Yes, when Z is greater than 83, when Z is greater than 83, then that element is prone to disintegration. Say they are radioactive. They become what? Radioactive. They become what? Radioactive. So you can write this down. Elements with atomic number greater than 83 have unstable nuclei and hence are radioactive. Elements with atomic number greater than 83 are unstable. They have unstable nuclei and hence are said to be what? Radioactive. We move to question number 32. Calculate the molality. Molality. Please, there is difference between molarity and molality. There is no mistake about the pronunciation. We have molality, we have molarity. So question number 32. So we should calculate the molality. So molality is equals to mass over molar mass times volume. So if you watch there, they gave us mass as 11.5. They gave us the molar mass there is 40 times the volume is 1.5. If you do your calculation very well, you'll be having this, which is option B. So mark it that molality is mass over molar mass times volume. Molality. Okay. That is question number 32. If you look at question number 33, we are given an equation, and the equation goes to us. First of all, let's bring out the parameters first. 33, it says, calculate the number of moles of chlorine ion when they gave us that volume is 1.7 liters. And they gave me 1.75 liters. And they gave me that concentration is 10 times 10 raised to the power minus 3 molar concentration. Remember that in this case, amount will be equal to CV. Mark this. That amount is equal to CV. So amount here will become 10 times 10 raised to the power minus 3 times the volume 1.75 liters. And if you calculate this well, you are going to be having 0.0175 moles. So coming to the equation given now. Now let's go to the equation given. In the equation given, we will find out that AlCl3 produce 3. So 1 mole of this actually gave 3 moles of this. Then how many moles? This mole will give how many this of this? So we have 0.017 moles of this. Will now give us how many moles of this? X mole. And if we do that, X becomes 0.0525 moles. Or you have 5.25 times 10 raised to the power minus 3 moles. Remember that the question says, question number 33, calculate the number of moles. So this is the number of moles that will be produced. When you have done this, they gave you this, they gave you this. Remember N is equal to CV, so we have this. This is the amount that has this concentration and this volume. So if the reaction goes on like this, then 1 mole of this produce this. Then how many? This mole will produce how many moles of chlorine? When you do the cross multiplication, you have that this mole will now produce 5.25 times 10 to the minus 3 moles of chlorine. Okay, and that will be option C, 5.2 times 10 to the minus 3. Question number 34. What volume of, question number 24 now, it says what volume, 34, what volume of 16 m, that is molar concentration, we have concentration is 16 m, okay, sulfuric acid must be used to prepare what volume, that is concentration, I have V1, I don't know what volume will be needed. What volume of this will be needed to prepare 1.5 liters? 1.5 liters. To prepare 1.5 liters of, we have second concentration there, 0.10. So we're looking for V1. Remember the formula as a C1, V1 equals to C2, V2. So V1, this is what we call dilution formula. This is well explained, or will be well explained in physics, in the chemist practical aspect of this study. V1 becomes C2 V2 over C1, and C2 is 0.10, V2 is 1.5, then C1 is 16. And if you do this calculation very well, we are going to be having 9.4 times 10 raised to the power minus 3 liters. 9.4 times 10, that is question number 34. That's question number 34. So we'll go to question number 35 now. Aluminium oxide reacts with carbon to form aluminum metal and CO2 according to the equation below. Okay. Aluminium oxide reacts, look at the equation they gave us here. They say 2Al2O3 plus 3, and this gave us 4Al plus 3CO2. Okay. The question I say, how many grams of aluminum metals are formed from 408 grams of aluminum oxide? Now watch something. Aluminum oxide is reacted with carbon to form aluminum metal. and CO2. The question now says, how many grams of aluminum metal, that means we're interested in aluminum metal, mark it, are formed from 408 grams of aluminum oxide? So I'm interested in aluminum oxide, both of them. So here they gave me, if you watch here now, 2 moles of this will give me 4 moles of this. 2 moles of this produce 4 moles of this. Now, if I have 2 moles of aluminum oxide, what is how many mass will it be? Remember, we have that our calculation that says that amount is equals to mass over molar mass. Amount is equals to mass over molar mass. If we have the amount to be 2, now the molar mass of aluminum oxide was given to us there as 102. Then what is going to be the mass? Mass will become 102 times 2. And when you do 102 times 2, you are going to be having 204. 102 times 2. 2 times 2 is 4. 2 times 0 is 0. 2 times 1 is 2. 204. 204 grams. So 2 moles is an equivalent to 204 grams. What are 4 moles of aluminum metal? What is going to be the mass? Using the same formula, we have that here is 4, here is M, and the molar mass of aluminum metal is 27. Then if you calculate for M, we have 27 times 4. And that will give you 108 grams. That means the equivalent of 4 moles of aluminum metal is 108 grams. So we have that 204 grams of aluminum oxide produce 108 grams of aluminum metal. Now, the question is now asking us that 408 grams of aluminum oxide will produce how many grams of aluminum metal? We cross multiply. My X becomes 408 times 108 over 204. And that will produce me 216 grams. That will produce me 216 grams. So I believe that calculation is very clear. So you are going to pick the one that you are interested in. They say this reaction happens. Then how many moles of this or how many grams of this will produce how many? So I'm not interested in the carbon. I'm not interested in the CO2. I'm only interested in aluminum oxide and aluminum metal, according to the question. So 2 moles of aluminum oxide produce 4 moles of aluminum metal. If there are 2 moles of aluminum oxide, if you check the mass will become 204 grams. In 4 moles of aluminum metal, we have 108 mass. That is the mass. Using this formula, you're still seeing on the board there. So if they now give you 408 grams of aluminum oxide, how many grams of aluminum metals will be produced? This is what we call stoichiometry. So that is how to go about that question. That's question number 35. We move to question number 36. How many grams of nitrogen must combine with hydrogen to form 6 moles of ammonia? How many grams of nitrogen must combine with hydrogen to form that moles of ammonia? So you are going to be able to write down the balance equation. The balance equation of this is 3 moles of hydrogen plus 1 mole of nitrogen will produce ammonia, 2 moles of ammonia. This is a balance equation. Now, going back to the question, it says, how many grams of nitrogen must combine with hydrogen to form 6 moles of ammonia? So they gave us nitrogen they say how many grams. In this place, we see that we are interested in how many grams of nitrogen. We are interested in nitrogen must combine with hydrogen. Must combine with hydrogen. How many grams of nitrogen must combine with hydrogen to form 6 moles of ammonia? We are interested in this, and we're interested in ammonia. If you watch, 1 mole of N2 gave 2 moles of ammonia. 1 mole of N2 gave 2 moles of ammonia. Then 6 moles of ammonia now. 6 moles of ammonia. How many moles of this will give 6 moles of ammonia? We're going to cross multiply. We have our X to be equals to now 6 times 1 over 2, which will give us 3 moles. So it will take 3 moles of nitrogen to produce 6 moles of ammonia. But remember, here we have 3 moles of nitrogen now, 3 moles of nitrogen. But then the question says we should bring it in gram. So we will recalculate, either you convert your 3 moles to gram, or you say 1 mole of nitrogen is equivalent to 14 grams of nitrogen, produces 2 moles of ammonia, which is equivalent to 34 grams of ammonia. Then how many grams of this we produce? 6 moles of ammonia is equivalent to 102 grams of ammonia. So when you do that cross multiplication, X becomes 102 times 14 over 34, and that will produce 42 grams of nitrogen. Okay, so we have 42 grams of nitrogen, or you say it is 3 moles of nitrogen. However, but the question is asking us about the mass. So 42 grams of nitrogen will be the one that is appropriate. And that question number 36 falls into the... Let's observe question number 36. It says, how many grams of nitrogen must combine with hydrogen to form 6 moles of ammonia? Look at the balanced chemical equation. Nitrogen plus hydrogen will give this. So in this case, it says how many grams of nitrogen, we're interested in nitrogen, must combine with hydrogen to form 6 moles of ammonia. We're interested in ammonia. If you observe here now, 1 mole of nitrogen produce 2 moles of ammonia according to this equation. Now, if you see, they said how many moles of nitrogen must combine with 6 moles? How many grams? That means they want us to give our answer in grams. So I'm going to convert these moles to gram. Remember that amount is equals to mass over molar mass. So amount here is for nitrogen 1. I want to get the mass, which is in gram. What is the molar mass for nitrogen? Look at molar mass for nitrogen is 28. So that the mass becomes 28 grams. Therefore, instead of me to write 1 mole, I can write 28 grams of this produce. For this one, it's also going to be mass equals to N times molar mass. The N here is 2. The molar mass of ammonia is 34. You see, 17 times 2, 34. This is 17. This is 14. 15, 16, 17. 17 times 2, 34. And 17 times 2, 34 times 2 now is 68. Is 68. So this will produce 68 grams. That means 2 moles is something as 68 grams. 1 mole is something as 28 grams. So if 28 grams of nitrogen will produce 68 grams of ammonia, then I say 6 moles. 6 moles. So if N is 6, then convert that one to mass also. We have 6 times 34. 6 times 34. 204. M equals to 204. So the question says 35. Question number 36. How many grams of nitrogen? How many grams of nitrogen will be produced by 6 moles? 6 moles is the same thing as 204 grams. So at this point, X becomes 204 times 28 over 68, and that will give us 84 grams. If you check in your calculator, and that becomes option B. Option B. Please note the molar mass of nitrogen and note the molar mass of ammonia. Okay, that's option B. We'll go to question number 17. It says, how many moles of ammonia can be formed? How many moles of ammonia can be formed? If 112 grams of nitrogen was combined with hydrogen according to the equation below, it's the same equation. So now how many, you see, we are still interested in nitrogen and ammonia. So in that same case, 1 mole of this produces 2 moles of this. Now they says how many moles? That means here we are interested in moles. 1 mole of this produces 2 moles. Then 112 grams of nitrogen. We are going to convert 112 gram to mole and put it under nitrogen. Remember that amount is equals to mass over molar mass. And they have given me molar mass as 112 gram. That is the molar mass as 112 gram. 112 gram of nitrogen. The molar mass of nitrogen is 28. So 112 divided by 28 produce 4. So we have it to be 4 moles. So 112 grams is something as 4 moles. Therefore, 4 moles of nitrogen will now produce how many moles? How many moles of ammonia? If you put that well, you have X equals to 2 times 4, all in moles. And X becomes 8 moles. X becomes 8 moles. And that is option number C. Option number C. 8 moles. Okay. We have seen that. Okay. We move to question number 38. Ethane gas. Ethane gas C2H2 reacts with oxygen to give carbon dioxide. How many grams of ethane are required to react with 28 moles of oxygen? Still the same stuff. Now the equation is given to us there as 2C2H6 plus 7O2. We have 4CO2 plus 6H2O. Okay. Let's look at what we are interested in. Say, how many moles of ammonia can be formed? We're interested in ethane gas reacts with oxygen to give carbon dioxide and water. How many grams of ethane, we're interested in ethane, are required to react with 28 moles of oxygen? We are interested in oxygen. Now, if you watch, 2 moles of ethane produce 7 moles of oxygen. You get that? Okay. Now, the question says, how many grams of ethane are required to react with 28 moles? So we have to convert this to grams. If 2 moles here, 2 moles, the grams will be what now? Remember that we have N there is now 2. We don't have our mass. While the molar mass of ethane there, molar mass of ethane there will be molar mass of ethane. Let's see that this is 12 times 2. 12 times 2 is 24. 24 plus 6. Okay. That will give me, okay, now. Then times 2. Times 2. That will produce 60 grams. 60 grams. Okay. That will produce 60 grams. Okay, let me come here. We have 60 grams. I think I've taught you how to do that. Of this produce 224 grams of this. Then X grams of this will produce 896 grams. Converting what we have there in question number 38. 28 moles. If you convert it to gram, you have this. So if you cross multiply, you have 896 times 60 over 224. And if you do that very well, you are going to have 240 grams. I believe this is very clear. Converting, if they want to answer in moles, you have to answer in grams. We have done it for ammonia 2 times, and we are doing it for this. I believe there is no much stressing myself about it anymore. Even if you go to question number 39, it says how many moles of water we produce. I think is the same thing all through. So we can do that That one, the equation is CH4 plus 2O2 produces CO2 plus 2H2O. So if you see 1 mole of this gave 2 moles of the other. 1 mole of this gave 2 mole of this. Okay, then 0.025 moles, if you convert, will give X mole of this. So X becomes 0.025 times 2, which will give us 0.05 moles of what? Water. You see that 1 mole of this gave 2 moles of this. 1 mole of this gave 2 moles of this. Then 0.025 moles of this will give how many moles of water? And at the end of the day, you get that. So we'll go to question number 40. How many atoms are present in this of iron metal? Remember that atoms, number of atoms present. We have done that severally. That we said that number of particle is equals to amount times Avogadro number, which you can also write as mass over molar mass times Avogadro number. If you follow this strictly, you'll be able to get number 40. Okay, number 41. The smallest particle of an element which can take place in them is atom. I think we know that. 42. A neutral atom in an element in which the number of protons in the nucleus is equal to the number of neutrons. A neutral atom is an element in which the number of protons in the nucleus is equal to the number of dash electron. Neutron and electron must be equal so that the atom becomes neutral. Remember that proton is positive, electron is negative. When they are equal, they cancel out and the atom becomes neutral. That's question number 41. 42. 43. The number of protons in a nucleus of an atom is called the atomic number. It's called the atomic number. That is option A for 43. Option 44. Which of the following properties increases down the group in the periodic table? That will talk about atomic radii. Atomic radii. Question number 44 is atomic radii. Is that 44? Okay. 44, atomic radius, or you call radii. 45, name the property of element that increases across the period and down the group in a periodic periodic table. Name the property of atom that increases across the period and it increases across the period and down the group in periodic table. Okay. Question number 45. Option A is the answer, which it says is 44. Which of the following property increases down the group in the periodic table? We say is atomic radii. 45. Name the property of an element of an atom that increases across the period and down the group. 45. And we say question 45 is A. That is ionization energy. Ionization energy. Very correct. 45. 46. What is the trend of the degree of electropositivity of an element in periodic table? The option is A. 46. Decreases across a period. Yes, electropositivity decreases across a period. Then 47. Which of the following group 1 element has the highest ionization energy? Okay. The one that has the highest ionization energy is lithium, which is option A. Now, let me say something about all this we have been saying. We say, moving down the group, atomic size increases. When you're moving down the group, atomic size increases, and the number of inner shell also increases, thereby increasing the magnitude of screening effect, and consequently, the ionization energy decreases. So when you're moving down the group, ionization energy will do what? Decreases. Okay, hence, lithium has the highest first ionization potential among the alkali metals. Lithium has the highest. So 48. If electronic configuration of an element is given as what you are saying there, what is the following state? Which of the following statement about X is false? Which of the following statement about X is false? If you look at option A, it says it has 5 electrons in the valence shell. That's wrong. It doesn't have 5 electrons in the valence shell. It doesn't have 5 electrons in the valence shell. If you want to check that, you can check that out. That's question number 48. 5 electrons in the valence shell. Let's see something about that. Total number of electrons here, there's the Z. The value of Z here in question number 48 is 5 plus 2 is 9. So even if you are drawing it, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the outermost shell, it has 1, 2, 3, 4, 5, 6, 7. 7 in the outermost shell. So it's not, that's question number 48. It has 5 electrons in the valence shell. No, it has, instead of 5, it is having 2, 4, 6, 7 electrons in the valence shell. Let's look at option B. It has atomic number of 9. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. Option B is correct. Option C says it is an halogen. Yes, almost partly filled. It is an halogen. Okay. Option D says it is a non-metal. Yes, it's a non-metal. It's not a metal. So that one, option A, is the correct answer. 49. The electronic configuration of an element is given as this. It can be deduced that X belongs to group. Okay, X belongs to group 6. No. X belongs to group 6. No. So let's see something about that. The unpaired electron of that. For question number 49, we have 1s2, 2s2, 2p6, 3s2, 2p2. That's exactly what it is. So this one is completely filled, completely filled, completely filled. 2s2 completely filled. Then this one is half filled. So okay. Number of unpaired electron here is 2. Number of unpaired electron here is 2. This one is unpaired, while this one is also unpaired. So has 2 unpaired electron. In that 49, I think there's no correct option. For me, don't think there's correct option. Because the first option says that they belong to group 6 of the periodic table. No, they don't. They don't belong to group 6. This is silicon, Si. This is silicon, Si. It's not, it doesn't belong to group 6. It doesn't belong to group 6. Then of the periodic table belongs to period 4. No, it's wrong. It doesn't belong to period 4. Has 3 unpaired electron in its atom. It's 2 unpaired, not 3. 2 unpaired, not 3. This is unpaired, this is unpaired. This is an empty, let alone saying paired. Okay, let alone saying paired. Okay, has 3 unpaired electrons, but if I'm going to go to any option, I can go for that one. Okay, has relative molecular mass of 16. No, Si does not have relative molecular mass of 16. So question number 50. An atom represented by this, which of the following deduced is correct? Okay, if you watch that place, you see that this is what is potassium alkaline metal, and option C will be correct. It is an alkaline metal. Yes, it's an alkaline metal. Number 51. Why do successive ionization energy of an atom always increase? Okay. The answer is option D. Enormous energy are involved. There's much energy involved. That's why it always increases. It needs more energy, so it will be increasing. And this brings us to the end of 2020-2021 as our part 1 in chemistry. So going through this past question, I want you to know that you have now got a lot of things to dive into when you're reading. Don't read shallow. As you're taking this class, you're noting down things that you need to go and pick up. This is chemistry. It's always diverse, very wild. So you need to pick up some informations from what we have done, especially from look at the topics that are more pronounced. Look at the topics that are more pronounced, periodic table, stoichiometry. Look at these topics that are more pronounced. Try and read them up again, a bit again, to get more information from them. And then I believe that you'll be well prepared. So we're going to meet next in the part 2, which is going to be 2022-2023. Thank you and God bless us.